All right, we're continuing with section 14.8, and we are on page 968. We're going to work on number 14, which says in exercises 9 through 17, evaluate the integral by using the given transformation. And they give us the double integral over r of y times cosine of xy dA, where r is bounded by the curves x times y equals pi over 2, x times y equals pi, y times 2 minus x, the quantity 2 minus x equals 2, and y times the quantity 2 minus x equals 4. And they give us our transformation like x equal 2v over the quantity u plus v, and y equal u plus v. So if we had x equals something and y equals something, then that is our step 3, not our step 1. So we're skipping step 1 here. And they gave us x equals 2v. Actually, x equals 2v over u plus v. And y equals u plus v. Now, remember I said I was going to stop sketching our region R because it's not really necessary, especially when they give us a transformation. Now, it may prove useful when you're not given a transformation, just so you can kind of write out what your equations are on the picture, but you really don't need to do it. Your region S is the one that you actually need to sketch. So now we'll go ahead and find our bounds for u and v. So the first equation they gave us was x times y equals pi over 2. Which is just a hyperbola. It looks like all of our equations are hyperbolas. So here, our x is 2v over u plus v, and then times the y, which is u plus v. So that just gives us 2v equals pi over 2. So 2v equals pi over 2, which just gives us v equals pi over 4. Next equation they gave us was x times y equals pi, which is also a hyperbola. So these just look like, both of these look like the graph y equals 1 over x, basically. And so then we have 2v equals pi this time. So that just tells us v equals pi over 2. And then the next one is y times the quantity 2 minus x equals 2. Y times the quantity 2 minus x equals 2. This is a hyperbola as well, so just think of it as being like x times y equals 2, but then you multiply the x by negative, which flips the whole thing across the y-axis, and then the 2 is going to give you a shift. So it's still just kind of like these. So we're going to have 4 hyperbolas that have this closed region. This region that they enclose, but we don't need to sketch the region though. So our y is u plus v. So we have the quantity u plus v times 2 minus our x, which is 2v over u plus v, and that equals 2. So from there, we distribute this, we get 2u plus 2v. I'm going to fit that over here. Probably not. All right, so we get 2u plus 2v, and then we distribute this to this term. The u plus v in the numerator and denominator cancel. So then we just end up with minus 2v equals 2. So we get 2u equals 2, which just tells us that u equals 1. And then lastly, y times the quantity 2 minus x equals 4, which is going to look the exact same as the left-hand side of this. The right-hand side is going to be equal to 4. So that's just 2u equals 4. So this is 2u equals 4. So u equals 2. All right, so now we can sketch our region S. Where are we all positive? Yes, we are. And this is in the UV plane. And u goes from 1 to 2. And v goes from pi over 4 to pi over 2. So pi over 4 to pi over 2. So we just end up with something like that. All right, so that's our region S, which is both a type 1 and a type 2 region. All right, so that was step 2. So now step 4 is our Jacobian. We don't need to do step 1. Step 1 would just be, again, if you want to do it, you can, if you wanted to solve this for u and v, but it's not necessary though. All right, so now 4, our Jacobian. So we need to take the partial of x with respect to u and v. So I'm going to rewrite x. So x is equal to 2v times u plus v to the negative 1. And since we can't see y, I'll just rewrite that as well. So y equals u plus v. So now the Jacobian, j of uv, the determinant of, so what are we going to have here? So the partial of this with respect to u, the two v's not going anywhere. The negative will come out front. Inside stays the same, then raised to the negative 2, and then times 1. So we're going to have negative 2v over u plus v, quantity squared, something down there. Partial of this with respect to v now, we're going to have to use the product rule here. So the derivative of this with respect to v is 2. And then this stays the same. So over u plus v. And then plus, that stays the same, 2v. And then times the derivative of this with respect to v, which is going to give us negative quantity u plus v to the negative 2. So we're going to get minus 2v over u plus v, quantity squared. So right, let me make sure I check my derivatives. All right. And now the partial of y with respect to u is just 1. And the partial of y with respect to v is just 1. So now we need to take this determinant, and we're going to get this minus, so that times that, which is 1. So this minus this thing, and so it's going to be this. That's going to have a negative sign in front of it. That's going to switch to a plus. So those two terms are going to cancel. So we'll just end up with negative 2 over u plus v for our Jacobian. All right, so now we're ready to go ahead and set up our integral. And see, can I squeeze that down here? I think so. So 5. Step 5. All right, so our u and v, u varies from 1 to 2, and v varies from pi over 4 to pi over 2. So 1 to 2, pi over 4 to pi over 2. And then our integral was initially y times cosine of xy. Y is u plus v. So we have the quantity u plus v times cosine of x times y. And that would, x times y is just going to be 2v. 2v. And then don't forget about the absolute value of your Jacobian. So that's going to be 2 times u plus v. And these were v's, so that's dv. And those were u's, so that's du. And notice without that Jacobian, the Jacobian actually makes our integral a lot easier because this and this cancel with one another. Alright, so I'll stop this video here and then we'll do another example from 14.8 in our next video.